we were doing some long division. Today, we're getting back into high school math. Because the reason we did long division yesterday is because if I want to divide polynomials by something that's not a monomial, we long divide. So, instructions might say divide, they might say simplify. I'm going to leave it with simplify. And today, it's really doing the same stuff we were doing with numbers, just the polynomial version. So, let's say I want to divide 3x squared minus 14x minus 5 by x minus 5. So, polynomial long division is just long division. So I got my big half box looking thing. What goes inside the box? The 3x squared minus 14x minus 5. It's the thing we are dividing into parts. It is the dividend. Now, when you put that in there are some stipulations that are required. Things that you didn't actually have to worry about when you were dividing straight numbers. When we were dividing numbers, such as 205 divided by 7. Doesn't really matter what number it's divided by. One of the things that numbers do that polynomials don't is numbers make sure that every placeholder is taken care of. The fact that I have 0 tens doesn't mean I don't leave a 0 there. Polynomials, on the other hand, when you have 0 of something, they get rid of it. Like x squared plus 9 got rid of the fact that there was 0 regular x's. So one of the things when it comes to dividing polynomials that you have to do is you have to make sure that there are no missing terms. If there are missing terms, you need to put them back on there. Furthermore, you need to make sure that polynomials are in standard form. The number 205 is never going to be rearranged in any other way and still be 205. Polynomials, on the other hand, you can rearrange them and have them be equivalent. So, key thing, when you are dividing, must be in standard form. Without any missing terms. What you're dividing by still goes to the left, and it holds in the same requirements. Has to be in standard form. You don't want any missing terms. We are not going to deal with a whole lot of larger polynomials there to where missing terms can be an option, but you do at least have to recognize that that's a thing. So, when we're doing straight long division, when we're doing long division with numbers, we ask ourselves the question, going back to this 205 divided by 7, we start asking ourselves, how many times does 7 fit into 2? And for that case, it's 0. When it comes to polynomials, you're going to do the same thing, but it's easier if I slightly reword the question. Because if I ask you how many times does, look at the first term of the polynomial you're dividing by, in this case x. If I asked you how many times x goes into 3x squared, some of you might be like, okay, I can figure that out. Others are going to be like, wait, what do you mean goes into? When we're asking that question, I'm going to reword it. And instead of asking how many times does it fit in, I'm going to ask, what do you have to multiply by to get? What do you have to multiply by x to get 3x squared? 3x. We put that above. And just like yesterday, after you figure out what that number is, you're going to take that number, or in this case, that monomial, and multiply it by what you're dividing by. And this is where yesterday I did this off to the side, and I said it's not a required step, but it helps with polynomials. I don't know why I just wrote a 2. I should be writing a 3 right there. And try that again. 3x specifically, and I'm going to multiply it by x minus 5. What is 3x times x? 3x squared. And I write it here, underneath. What is 3x times negative 5? Negative 15x. So we write it underneath just like we did. Now, as you write it underneath, assuming you didn't miss any of the missing terms, your like terms should be lined up. Are there like terms lined up? Are x squareds over x squareds, x's over x's? If they're not, something's wrong. What do you do as the next step in long division? You subtract. We're going to subtract. Here's the nice thing about polynomial division. Once you subtract, that first term, in this case 3x squared and 3x squared, should always cancel out. If it doesn't, you did something wrong. Negative 14x, be careful of the positives and negatives. Negative 14x minus a negative 15x is what? Positive x. Negative 14 minus a negative 15 is negative 14 plus 15. If it helps, if it makes it easier for you, you can distribute your negative through. Makes that a minus, makes that a plus. 3 minus 3, negative 14 plus 15. You can distribute the negative through if that makes it easier. And in fact, I typically do that. X, and then you bring down your next term, just like in regular long division. You see what multiplies, you multiply it, you subtract, you pull down. You see what multiplies, you multiply it, you subtract, you pull down. That is the process that you go through. Okay, what do I multiply by x to get x? 1. Positive 1 plus 1. Now I actually do the multiplication. The one that I just found, getting multiplied by x minus 5. Now that's a really easy one. 1 times anything is just what you had. X minus 5. Figure out what multiplies. Do the multiplication. Next step is subtract. And if it's easier, distribute that minus sign and combine like terms. Negative x plus 5. X plus a negative x cancels out. If it doesn't cancel out, you made a mistake. They should cancel out every time. Negative 5 plus 5? 0. I have no more terms to pull down, which means this is the remainder. What does it mean if we have a remainder of 0? The answer at the top is fully the final answer, 3x plus 1. It also means that it divided out nicely AKA x minus 5 was a factor of 3x squared plus minus 14x minus 5. So, same process, definitely uglier than regular long division. I'm not going to deny that. k cubed minus 90k squared plus 124k minus 23 getting divided by 8k minus 10. Okay, so I set up my long division. I set up my little box. What goes inside the box? Long one, the numerator, the thing that's getting divided by something. Do I need to modify anything about it, or is it okay? It's in standard form? Yes, no? Is it missing any terms? It goes from cubed to squared to regular to nothing. We're good. And the 8k minus 10 goes over here. And what is the question we now ask? What times 8k is equal to 8k cubed? We've already got the 8. So the number would be 1. What do you multiply by k to get k cubed? K squared. Because remember, when you're multiplying variables, you add the exponents. Okay. Then off to the side, I write out what I'm multiplying. What am I actually multiplying here? K squared is getting distributed into 8k minus 10. What you just got multiplies by what you're dividing by. K squared times 8k. 8k cubed. K squared minus 10, or times minus 10. Negative 10k squared. Figure out what multiplies, do the multiplication. Now what? Subtract. To make subtraction easier, we can always distribute that negative to the terms and add the negative version. Distribute the negative there, I get negative. Distribute the negative there, I get positive. And now I'm going to add. 8k cubed minus 8k cubed. Cancels. Should it cancel? Yes, always. Negative 90k squared plus 10k squared. Negative 80. Don't forget the k squared. Determine what multiplies, multiply it, subtract, and then, before we repeat ourselves, what's the last thing I got to do? Pull down the next term. Plus 124k gets pulled down. And repeat. What do you multiply by 8k to get negative 80k squared? Negative 10k. And off to the side I multiply it. Negative 10k getting multiplied by 8k minus 10. Negative 80k squared positive 100K. Subtract, or to make it easier, distribute that negative. This was negative, becomes positive. This was positive, becomes negative, and now we're adding. Negative 80K squared plus positive 80K squared. Cancels. It's a good thing. 124K plus a negative 100K. Positive 24K. Bring down your next term. What do you multiply by 8K to get 24K? Positive 3. So plus 3. 3 times 8K minus 10. 24K minus 30. I subtract, and to make it easier, I'm going to distribute the negative and add. 24K minus 24K cancels. Negative 23 plus 30 is 7. Do I have any more terms to bring down? No. Now, actually, there is one other slight difference when dividing polynomials. Okay, maybe 2-ish. And that has to deal with the remainder. The remainder with regular long division always showed up as soon as you had nothing else to pull down and you couldn't put something into it anymore. The remainder shows up with long division as soon as this has fewer variables than this. As soon as the power on this variable is smaller than the power on this one. This one's power is 1. This one's power is 0. Its degree is 0. Its exponent is 0. So, that's the remainder. How did we deal with a remainder when we had it in long division? We wrote a fraction. We do the same thing with polynomials. Our answer is k squared minus 10k plus 3. Now, with regular numbers, you just wrote the fraction directly after the number because that's how mixed numbers worked. If I had 5 1/2, I just write it like that. But in all technicality, 5 1/2 is 5 plus 1/2. With polynomials, you cannot stick a fraction up beside the 3. It changes it to multiplication with polynomials. It's not like regular numbers. So, plus the remainder is the numerator. What you're dividing by is the denominator. Now, in all technicality, sometimes you can simplify that fraction. The times that you can simplify that fraction is when all of the whole numbers divide by something. Does 7, 8, and 10 all divide by the same thing? No. If I had a situation like 2 over 2x minus 4, could that simplify? Yes, because they all divide by 2, and I would do that, and I would get 1 over x minus 2. It just doesn't apply here. But this is my final answer. 5n to the 4th plus 33n cubed minus 14n squared minus 4 getting divided by 5n minus 2. This goes inside. Do I write it exactly as is? Is it in the right form? No. It's missing a term. Which term is it missing? 4, 3, 2. Where's the n to the first power? Not there. How many n to the first powers do I have? In here, I need to add a 0n to the first. I can't have those missing terms. If I have them, I've got to add them. Be careful. They like to put it in standard form in a way that you miss that it's missing that term. It was so easy to look at this and say, yeah, powers are decreasing, we're good. And they especially like to do it with that regular n term because how often do you notice 4, 3, 2, it disappeared? Do you typically have the 1 there? No, so people tend not to notice it, so keep an eye on that. 5n to the 4th plus 33n cubed minus 14n squared. Here's where I put the regular n's, minus 4. Okay, I've got it written out. Now I got to do some dividing. Ava Grace, where should I start? Find what multiplies by 5n to become 5n to the 4th. And now, what is that? What multiplies by this to get this? N to the power of 3. Beautiful. Preston, what do I do next? Do what with that 5n minus 2? I do something with it. We just got this number. Off to the side. Do what with it? Multiply by that. Jonah, what will I get when I distribute n cubed into 5n minus 2? Beautiful. Isabella. Now what? Subtract. Or the easier version I could do is what? Distribute the negative and add. Negative, positive, add. Owen, what do I get when I do that? Because that cancels. Brenna. Now what? Make sure you're bringing the negative with it, but yes. Jacob, what comes next? We're repeating the process. We just pulled something down. We ask, what do we multiply by 5n? To get 35n squared. 7 what? Guys, let him think. He's capable. 7n squared. 7n squared. It's what do we multiply by this to get this? Positive 7n squared. Caden. Now what?
7n squared
n squared gets multiplied by the 5n minus 2 off to the side. LZ, what do I get?
35 cubed and 14 squared.
Positive or negative?
Negative.
Bryden, what do I get when I subtract those? Nope. 35n cubed canceled. I distribute my negative. Don't they also cancel? I get 0 n squareds. I pull down, I get 0 n's. Multiplying by 5n to get 0 n squared is 0 n or just 0. Now when we're doing regular long division with numbers, do I have to put the 0 up top? Absolutely. When I'm doing it with polynomials, do we typically write that we get 0 n at this point? No. Is it wrong to do it? No. But you don't have to. If I were to do that, I would get 0 n squared, and all of a sudden I would have another 0 n, and I would see, what do I multiply by 5n to get 0 n?
0.
Also 0. Do I need to do it? No. When you've got polynomials, when you end up with zeros, ignore them until you get to things that are not 0. Ideally, you want 2 terms here. But do I have 2 terms left to pull down? No. If I had 2 terms left to pull down, I would pull them down and I would continue the process. But is it the remainder? And the question is, look at the exponents on the variable here. Look at the degree, in other words. What's the degree of a negative 4? 0. What's the degree of 5n?
1.
Is this degree smaller?
Yes.
Then it's the remainder. That is the remainder. Isaac, what's that make our final answer?
N cubed plus 7n squared. Negative 4 over 5n minus 2.
What needs to go in between?
Plus.
Plus. N cubed plus 7n squared plus negative 4 over 5n minus 2, or more traditionally, n cubed plus 7n squared minus 4 over 5n minus 2. If it's negative, they generally put the negative out front. I don't care if you leave it like that. This is more traditional. I got one final example for you today. Do you notice anything different about this problem as compared to the previous 3? There's no adding or subtraction in this. What do you call it when there's no adding or subtraction in the polynomial? It's a monomial. When you divide by a monomial, you do not do long division. How do we divide by monomials? We did it a couple days ago. Change them all into fractions. 3x squared is getting divided by 2x. 12x is getting divided by 2x. Minus 6 is getting divided by 2x. And you simplify the fractions. 3x over 2 plus 6 minus 3 over x. One common thing I see is people see division and now they're like, okay, I'm going to do long division. You only do long division if you're dividing by a polynomial, not a monomial. It needs to have multiple terms. It needs to be a binomial or a trinomial, or it could be bigger. It doesn't matter. But the thing you're dividing by, if it's a monomial, long division will not work. So keep an eye on that. I got a worksheet for y'all. Did I show you guys your quizzes yesterday? No? Okay. I'll show you guys your quizzes from the other day.